Hello everyone, my name is Deepika Sharma and today I'll explain the topic switching techniques under subject computer networks. So first of all, what is switching techniques? For transmission of data beyond local area, communication is achieved by transmitting data from source to destination through a network of intermediate nodes. These nodes are called switching nodes. This method of transmitting data is called switching. So, in the large networks, there might be multiple paths linking sender and receiver. Information may be switched as it travels through various communication channels. There are three typical switching techniques available for digital traffic, and the different types of switching techniques are employed to provide communication between two computers, and these are circuit switching, massive switching, and packet switching. So, first of all, what is circuit switching? Circuit switching is a technique that directly connects the sender and the receiver in an unbroken path. Telephone switching equipment, for example, establishes a path that connects the caller's telephone to the receiver's telephone by making a physical connection. In this type of switching technique, once a connection is established, a dedicated path exists between both ends until the connection is terminated. And in this technique, first the complete physical connection between two computers is established, and then the data is transmitted from the source computer to the destination computer. That is, when a computer places a phone call, the switching equipment within the telephone system seeks out a physical copper path all the way from sender telephone to the receiver's telephone. The important property of this switching technique is to set up an end-to-end path between computers before any data can be sent. So there is a direct physical connection between two devices is established, and the routing decision must be made when the circuit is first established, but decisions cannot be made after that time. And switching and circuit switching networks operate almost the same way as the telephone system works. I already explained, and a complete end-to-end path must exist before communication can take place. So the computer initiating the data transfer must ask for a connection to the destination. And before the establishment of the connection, the decision must send the acknowledgement to the source node to indicate that it is ready and willing to send or receive data. And next are the main advantages and disadvantages of circuit switching. The main advantage of the circuit switching is the connection channels is dedicated, and there are some, we can consider some of the other advantages, that are the circuit is very simple. Once the circuit is established, the network is efficiently uh, transparent to users, and the delay at each node is negligible. And we can also consider one that, as an advantage, information is transmitted at fixed data rate with no delay other than propagation delay. And next, I got the disadvantages. First is possible long wait to establish a connection, 10 seconds more on long distance or international calls, during which no data can be transmitted. This is one of the disadvantage. Second, more expensive than other switching techniques because a dedicated path is required for each connection. And third one is inefficient use of the communication channel because the channel is not used when the connection systems are not used, and channel capacity might be is not properly utilized, or there is a delay prior to signal transfer or call establishment, and we can also say it is less flexible. It is suitable for voice communication but not for data communication. So that was all about circuit switching. Now the next switching technique is message switching. Now in this technique, the source computer sends data or the message to the switching office first, which stores the data in its buffer. It then looks for a free link to another switching office and then sends the data to the office. This process is continued till the data are delivered to the destination computers. In message switching, there is no need to establish a dedicated path between two stations. When a station sends a message, the destination address is appended to the message, and then the message is then transmitted through the network in its area from node to node, and each node receives the entire message, stores it in its entity on disk, and then transmits the message to the next node. This type of network is also called store and forward network. Owing to its working principle, it is also known as store and forward. That is, store first, forward later, once jump at a one jump at a time. And there is a diagram of message switching. A message switching node is typically a general purpose computer. The device needs sufficient secondary storage capacity to store the incoming messages, which could be long. A time delay is introduced using this type of scheme due to store and forward time, plus the time required to find the next node in the transmission path. And in this, the main thing is first is stores the data, then forward the data after checking its destination address. And the main advantages of message switching are channel efficiency can be greater compared to circuit switched system because more devices are sharing the channel, and second is traffic congestion can be reduced because messages may be temporarily stored in route. Third is message priorities can be established due to store and forward technique, and message broadcasting can be achieved with the use of broadcast address appended in the message, and channel is properly utilized. And one more is to provide high level network services to unintelligent device. Now next are the disadvantages. In message switching, it is not compatible with interactive applications. And second one is store and forward devices are expensive because they must have large disks to hold potentially long messages. And there may be delay is here at each node and requirement of large capacity storage media at each node. Now next is packet switching. Packet switching to be a solution that tries to combine the advantages of message and circuit switching and to minimize the disadvantages of both. There are two methods of packet switching. First is datagram and virtual switching. In packet switching, like with the message switching, there is no limit on block size. In contrast, packet switches places a tight upper limit on block size, a fixed size of packet which can be transmitted across the network is specified. Another point of its difference from message switching is that data packets are stored on the disk in message switching, whereas the packet in packet switching, all the packets of fixed size are stored in the main memory. So in this way, it improves the performance as the access time is reduced, thus the throughput of the network is improved because data is saved in the main memory and it can be easily accessed by the processor. So it improves the overall performance and efficiency of our system. And the message is transmitted in the form of bits of variable length blocks called packets. The maximum length of the packet is established by the network. Longer transmission are broken into multiple packets. Each packet contains header with control information along with the data, and the packets are sent over the network node to node. The packet is stored then routed according to the header information. Typically, the packet size in 1000 octets, and the two main approaches for packet switching are datagram and virtual circuit. And there are some other points in packet switching, that in both packet switching methods a message is broken into small pods called packets, and each packet is tagged with appropriate source and destination addresses. Since packets have a strictly defined maximum length, they can be stored in main memory area instead of disk. Therefore, access delay and cost are minimized. And also the transmission speeds between nodes are optimized. With current technology, packets are generally accepted onto the network on a first come first served basis. If the network becomes overloaded, packets are delayed and discarded. And there is in packet switching, the analog signal from your phone is converted into a digital data stream. That series of digital bits is then divided into relatively teeny clusters of bits called packets. So here all we have one example. Each packet has its beginning, the digital address, a long number to which it is being sent, and the system blasts out all those tiny packets as fast as it can, and they travel across the nation's digital backbone systems to their destination. Hmm. The telephones, or rather the telephone systems of a person you are calling. And next, we have the one type of packet switching, that is datagram packets. In datagram packets, switching is similar to message switching in that each packet is self-contained unit with complete addressing information attached, and this allows packet to take a variety of possible paths through the network. So the packets, each with the same destination address, do not follow the same route, and they may arrive out of sequence at the exit point node or the destination. Reordering is done at the destination point based on the sequence number of the packets, and it is also possible for a packet to be destroyed if one of the nodes on its way is crashed momentarily. Thus, all its queued packet may be lost. Or in datagram approach, no dedicated path is established and all the packets belong to the same message need not to go by one route to reach the destination. So the packets can go from different paths to reach their order of reaching destination may be different from starting order. And second type, we have virtual switching. In virtual circuit approach, a pre-planned route is established before any data packets are sent. A logical connection is established when first a sender sends a call request packet to the receiver, and second, the receiver send back an acknowledged packet, call accepted packet, to the sender if the sender if the receiver agrees on conversational parameters, and the conversational parameter can be maximum packet sizes, path to the taken, and the other variables necessary to establish and maintain the conversation. Virtual circuits imply acknowledgements, flow control, and error control, so virtual circuits can be more reliable or are more reliable. That is, they have the capability to inform upper protocol layers it if a transmission problem occurs, or in virtual circuit the relationship between all packets belonging to the same message is preserved. A single route is chosen between sender and receiver. When the data are sent, the packets have to follow the same route one after another along that route. In these, the order is same as in the starting. And in virtual circuit, the route between station does not mean that this is dedicated path as in circuit switching. If we compare both of them, a packet is still buffered at each node and queued for output over a line. And the difference between virtual circuit and datagram approaches are: first, with virtual circuit, the node does not need to make a routing decision for each packet, and it is made only once for all packets using the virtual circuit. And in virtual circuit switching, it guarantees that the packet arrives in the order they sent. Second, there are no duplicates or omissions. Third, there are no errors with high probability, regardless of how they are implemented internally. Now, next are the main advantages and disadvantages of packet switching. First of all, advantages: packet switching is cost effective because switching devices do not need massive amount of secondary storage. And next point is, packet switching offers improved delay characteristics because there are no long messages in the queue, because the size of the packet is fixed in packet switching, but there is no limit of packet in message switching. And the third point is, packet can be rerouted if there is any problem such as busy or disabled links. And the last is, the advantage of packet switches is that many network users can share the same channel at the same time. So packet switching can maximize link efficiency for optimal use of link bandwidth. Now, the disadvantages of packet switching are: protocols for packet switching are typically more complex. It can add some initial cost in implementation, and if packet is lost, sender needs to retransmit the data. The another disadvantage is that packet switching systems still cannot deliver the same quality as dedicated circuits in application requiring very little delay, like voice conversation or moving images. And there are also some advantages and disadvantages of datagram switching. Like in datagram switches, the switching. The advantages are the call setup phase is avoided. Second, it is more flexible and it is more reliable. But there are also disadvantages in datagram switching, that is the order of reaching is not same, and for longer and larger packets it is not suitable. Second, the advantages of virtual switching. First is no need of routing decisions. Second, if station wants to exchange data over a period of time, then it will provides error control. And the third point is it provides sequencing, as order of packets are same at the destination as on the transmission point, and packets should transmit more rapidly with a virtual circuit. And the disadvantages of virtual circuit are if node fails all the sorry if node fails, all virtual circuits that pass through that node are lost. Packets are predefined rules. It is more difficult to adapt to congestion. So this is all about switching and the different switching techniques that are circuit, message and packet switching. Hope this will help you to understand the topic of switching. Thank you.